Force and pressure, class 8. Force, we come across it in our day-to-day life. Force is required to open a door, pick up a glass of water, to have your breakfast, lunch, dinner, to study, to move, to run, to play, all requires force. In this top chapter, we are going to study about the causes of force, types of force, relationship between force and pressure, atmospheric pressure, effects of force, relationship between forces and pressure, pressure exerted by liquids, and types of forces. Force. A force is a push or a pull or both. A force cannot be seen, but we can feel and observe the effects of force. Push. A force to move an object away from our bodies is called push, and pull is a force when we apply on a body to move it away, to move it towards our body. Playing with a guitar, the push, sawing wood, push, scrubbing of floor, pull, rowing a boat is a pull. That is, these are examples of push and pull. In the diagram you see a boy is pulling the table towards him, and in second diagram the boy is pushing the table away from him. Second figure, first boy is pushing the box, pulling the box towards him, and the second boy is pushing the box away from him. Force and pressure. Force is a push or a pull. Here the person is pushing the car. The second boy is kicking the football. Force cannot be seen, but we can feel and observe the effects of force. It is denoted by capital F. SI unit is Newton. The direction in which a body is pushed or pulled is called direction of force. Pressing a switch, launching of rocket, pushing a trolley, kicking a ball, knocking a nail are the examples of force. Force are due to interactions. When you come in contact with a force, then there is interaction. Suppose you want to pick up a glass of water, you have to move your hand to the tumbler and lift the tumbler. So interaction is required. While cycling, you have to put your feet on the pedal and make a contact and then press the pedal, the bicycle starts moving. Interaction is necessary. In second diagram, the boys are pushing the box, interaction is necessary. Third diagram, both the boys are pushing the box, but the box is not moving because the forces are in opposite direction. Interaction is there, but the box is not moving. Effects of force. Force can move a stationary body. Force can change the speed of a moving body. Force can change the shape of a body. Force can change the direction of the moving body. Force can stop a moving body. Now there's a ball, we can make a stationary body move. The ball is moving. We throw, the ball is moving. Force can change the speed of the body. We can throw it faster. The speed can be more. Force can stop a moving body. Now the body has been stopped. The ball has been stopped. Force can change the direction of the moving body. I can throw the ball away. The direction can be changed. Force can change the shape of the body. This is the ball here. You can see a smiley on the face, and if I press it, the shape gets deformed. Force can change the shape. This is a matchstick. If I apply force on this, it will be broken into parts. So force can change the shape. There's a rubber band. I am stretching it. The length elongates. Force can change the shape. Apply force is removed. Again, it is coming to its initial position. Force can produce motion. The ball is kicked, football is kicked. Force can produce motion. Force can stop a body. A ball is thrown towards you, you catch it. So the force can stop a body. The shuttlecock is being forced to move in another direction. The direction can be changed. Force can change the speed of the body. The ball is thrown towards the batsman and the batsman flicks it with a higher speed. So force can change the speed. Even the speed can be reduced. Force can change the shape of the body. As you have seen here, force can change the shape. The shape of the ball has been changed. Force can do various things as we have seen here. Types of forces: contact force, muscular force, frictional force, and mechanical force. These are examples of contact force. Non-contact force, magnetic force, electrostatic force, and gravitational force. To lift any body, we require muscular force. When an object moves on another object, for example, bicycle is moving on the ground, there's a force between ground and the bicycle. When you move on the ground, there's force between your sleepers and the ground. Mechanical force: whenever any machine moves, there is mechanical force. Magnetic force: you see, these are two pieces of magnets, first one and second one. I'm bringing it close to it. Both of them, they contact. Example of magnetic force. So there's magnetic force, here force is there, magnetic force. Electrostatic force: there are two like charges, positive charges, they repel. Unlike charges, positive and negative attract. Gravitational force: the matchbox, it's allowed to move down. If I release it, it comes down. This is an example of non-gravitational force. Earth pulls every object towards it. Types of forces: contact forces and non-contact forces. Muscular force. Muscular force. When you apply a muscle power, then the object can move. To move, we require muscular power, muscular force. To run, to play badminton, to play cricket, you require muscular power. To lift your pencil, write, requires muscular power. To change the page of your notebook, requires muscular power. Frictional force. Whenever you cycle, the cycle is moving forward, but you see in red and blue the direction where the frictional force is applied. So frictional force always occurs between two surfaces and the direction is always opposite to the direction of motion. Second diagram, a trolley is moving here and the person is pushing it in the forward direction. The frictional force is in opposite direction. Mechanical force. A mechanical force can be defined as the force that features some direct contact between the two objects and results in the production of a change in the state of the object. Mechanical force. Force applied by machines is called mechanical force. It is used in tractors, motors, vehicles, cars, etc. You can see here examples of forces. Forces can be classified into the second category, that is non-contact forces. Magnetic force. Magnetic force has attraction as well as repulsion. You see, this is attraction, and here if I change the direction of this magnet, it's not attracting. See, it's not attracting. That is what repulsion. This is the repulsive force, repulsion. So there is attractive force, attraction, repulsive force, repulsion. So magnetic forces are attractive as well as repulsive. So like poles repel, unlike poles attract. Gravitational force. When the object is released, then it goes down. That is an example of gravitational force, because Earth is pulling every object towards it. The gravitational force is a force that attracts any two objects with mass. We call the gravitational force attractive because it always tries to pull masses together. It never pushes them apart. In fact, every object, including you, is pulling on every other object in the entire universe. This is called as Newton's universal law of gravitation. Difference between gravitation and gravity. The gravitation means that two objects are being attracted towards each other in this universe, and gravity means Earth is pulling every object towards it. This is called as gravity. Electrostatic force. You see a balloon and rub it on your hairs, dry hairs, and small pieces of paper, they attract towards the balloon, and this is your attraction. So it is an example of electrostatic force. The electrostatic force is also known as the Coulomb force or Coulomb interaction. It's the attractive or repulsive force between two electrically charged objects. Like charges, that means positive and positive charge repel, and positive and negative charge attract. You see a magnet here. Magnet attracts iron pieces. If you have iron pieces, then the magnet will attract those iron pieces. That is an example of electrostatic force. Gravitational force, when you release a ball, it goes down. That is an example of gravitational force.